Hello! In this video I'm just very quickly going to explain to you what is meant when physicists talk about Schrödinger's cat. Some of you may have already heard about it. It's not actually part of the course, but it's a classic example that's used to explain quantum physics, and even though quantum physics is outside of our course, I thought I'd just take a little bit of your time to explain to you what it means. So basically, a couple of quotes that relate to quantum physics, in that most of the physics that we're doing in Year 12 physics is referred to as classical physics, based around Newton's laws, and pretty much explains the observable universe that we see. Whereas quantum mechanics explains what's happening on the atomic scale, and it gets particularly weird, and it's a little bit harder for us to understand because it's based a lot about probabilities of things happening and things like that. And so a couple of quotes for you from some famous physicists. Anyone who's not shocked by quantum theory has not understood it. That's Bohr. And Bohr and Einstein were around when quantum theory first came out as a major theory, and Einstein in particular really wrestled with it and wasn't particularly happy. His famous quote about God not playing dice relates to quantum theory and the use of probabilities, but since then, basically, quantum theory has gone in leaps and bounds and is used as a very predictive theory, and it has been experimentally proven over and over and over again, as shown by the Higgs boson. Right, there should be another quote where Schrödinger, who actually is talking about quantum theory, I don't like it, and I'm sorry I ever had anything to do with it. That's a nice quote. And Rutherford, another famous physicist, all science is either physics or stamp collecting. And he got in a lot of trouble for that, because every other science other than physicists said, oh, we're serious, we're important. But he later went on to explain in a little bit more detail what he meant by it. What he meant was most sciences involve putting things into pigeonhole, classifying things and ordering things and having theories to explain why things are the way they are, whereas physics has the potential, and does, go into the unknown, goes into the world that is pretty much beyond our perception, and therefore it's very different from biology or even geology. Heaven forbid me saying that. So, what is this quantum madness, and why is it used? Why is Schrödinger's cat used as an illustration of it? Well, this is a graphic of it. Basically, you have his cat in a box, and in the box there is a radioactive atom, and that atom has a 50-50 chance of decaying. And if it decays, there's a Geiger counter that is triggered. And if the Geiger counter is triggered, a hammer breaks a poison bottle, and the poison bottle kills the cat. So, and all this is sealed up in a box which you can't look into, and you can't sense, and you can't you can't x-ray, you can't do anything. And so the point is that the cat, for us, as an example of quantum theory, the cat can be viewed as being either dead or alive. If the atom has decayed, it's dead. If it hasn't decayed, it's alive. And until that box is open, the cat is theoretically in both those states. And it's only the opening of the box that collapses those two states into one state, either dead or alive. Now, this doesn't work on the macroscopic scale, and that's one of the reasons Schrödinger wasn't particularly happy when this example was used over and over again, because a lot of people misconstrued it. But what it is an analogy of is what's happening on the atomic scale, on the quantum scale. So here's a whole lot of words. This time it's deadly cyanide, radioactive decay, box is open. Quantum theory is that when the box is closed and the cat is not observed, because as soon as you observe, you collapse the quantum state. And the quantum state for this cat is alive or dead. And so it's said to be in a superposition of two possible states. And it will be in a state of being both dead and alive. And quantum physicists would think of that and be acceptable with that. Whereas if you asked people in the street, can a cat be both dead and alive at the same time? They'd say no. And so it's a different way of viewing the quantum world. So opening the box collapses the wave function to either being alive or dead. And there's a joke. There's Schrödinger and the RSPCA, and it says, and you're quite sure it's just a hypothetical cat. Back to the serious stuff in the next video. See ya.